Bill Nye the Science Guy.
Bill Nye the Science Guy.
Bill Nye the Science Guy. Science rules. Bill Nye the Science Guy. Inertia is a property of matter.
Bill Nye the Science Guy.
Bill. T minus 10 seconds. Bill Nye the Science Guy.
Meiosis is the reason we have so much variation and we're not the spitting image of our parents.
I got all my sisters with me. We are family. Get up, everybody, and sing. We are family.
A good way to remember the stages of meiosis is with PMAT. PMAT is prophase, metaphase, anaphase, and telophase. Prophase 1 is the first stage of meiosis. A good way to remember that is that pro is a Greek root for before. So what happens in prophase is that two chromosomes actually pair up with their homologous pairs. So if I have a tennis ball and I have another tennis ball, these two would actually come together and be a homologous pair, which means that they're physically similar, but they have different genetic information. But what's really cool about this phase is that crossing over actually occurs and they exchange genetic information between them.
So the next phase in meiosis is metaphase 1. And you have your homologous pairs, your chromosomes are still in their pairs. They come to the metaphase plate and they line up randomly, which is another source of genetic variation within cells. So randomly, you have them come to line up with the metaphase plate.
In this example, the Wilson tennis balls represent the maternal chromosomes and the pen represent the paternal chromosomes. During anaphase 1, the chromosomes break up.
In telophase 1, it actually becomes two cells. So now we have two cells, each have one paternal chromosome and one maternal chromosome.
You did it.
Okay.
So, after interkinesis, we start with prophase again. This is one of the cells that we got from meiosis 1. And in prophase 2, the nuclear envelope breaks down and a spindle starts to form between each chromosome from the homologous pair.
In metaphase 2, the chromosomes line up at the metaphase plate, but they line up individually because there are no more homologous pairs.
Okay, so now we are in anaphase 2. Instead of using the tennis balls for this, I'm actually going to use these to represent the chromosomes. So in each chromosome, there are two sister chromatids. And actually what's going to end up happening is the sister chromatids are going to split up in both of the cells. So I'm going to rip these in half to show you. It's going to happen here too. And what's going to happen is one from each cell is going to go to different poles again, making them daughter chromosomes.
So, the two daughter chromosomes that we have on one side go off to form their own cell, and then the two daughter chromosomes on the other side form a different cell. And if you remember, at the end of meiosis 1, we had two cells. And since meiosis 2 takes place in both those cells, we actually end up with a total of 4 different haploid cells. And because of the crossing over and the random alignment in meiosis 1, each daughter chromosome is made up of different genes from the maternal and paternal side. So each of the haploid cells happens to have different genetic information, and they each have individual genetic information. And these haploid cells become the reproductive cells of the